So according to the Fermat's principle, we realize that the path that the light will travel from one place to other place must take the minimum time, and that translate into the law of reflection naturally. So the nature is like hard coded already. So no need to think much about
Sir,
nature.
what is French distance?
Pardon?
What is French distance?
What is Fresnel's distance?
Oh,
Ah, so Fresnel distance is like it's a range beyond which the validity of geometrical optics is not there. So geometrical optics, as you know, is not always applicable. So the concept of ray is limited for the small range. At a large distance, the behavior becomes a wave-like behavior. You can say uh, it exhibit the diffraction pattern instead of the real behavior which gives you the point object and point image. So fractional distance is the distance beyond which you cannot apply the ray optics. You can think this way. Yes.
yes.
So the fractional distance beyond this distance,
Sir, what have you started something to
yes,
teach?
beyond this distance, geometrical optics is not applicable. So what exactly is fractional distance? I will explain in the chapter of wave optics because it's a part of wave optics. So we as a human being, or for that purpose, any living creature, let's say animals or birds or us. So we have an eye. Eye is like the window for the light. So of course we don't see using eye. Eye is just a window which will let the light to enter. And the purpose of eye is to control the entrance of the light ray within the, of course, human body, you can say. And the pupil is the window. You open it, you let the light, and by shrinking and expanding the pupil, or sorry, the iris like the shutter of a camera. So the iris will open and close, and that's how the human eye is able to control the light ray. So we need certain intensity of light to see the object like clearly. So when the light is really dim, then the iris will open to the max, will allow all the light ray to enter and will cast the image. So what we call image is basically the impression that the light creates on the retina. And when the light ray will fall on the retina coming from a source, it will activate the rods and cones, which will create some optical signal, which will travel to the brain. That signal will, after reaching the brain will be able to decode those frequencies, those signals, and it will recreate the perception of object. So what we discussed in the last lecture, if you remember, that we don't see object, we perceive object, and what we see is called light, correct? So we see light and we perceive. What do you perceive?
Object.
Object is not seen, and because human being is only depending on the light, so it can be deceived easily. So for example, let's say a person is sitting in a basement and using the projector, the person is shown to be standing here. So using the various projector mechanism, of course we'll learn about the projector if you go into the filmmaking and all. So the magician, what they do is we have a live person here, and then they create a cast the image here. So in the box the person is actually entering the box in the bottom of the stage, and then they prick the swords across it, and the person comes untouched or without any injury. And how it is possible? Of course, what you see is the projection, So they use the multiple reflectors, multiple angle at which you tend to perceive the human being standing there. But what you see exactly is the image. So in a way, you can say the geometry optics, if someone understands really well, are the magicians. I mean, they really know how to play with the light, how to play with the perception, and every magic which they perform is an act of deceive. So they deceive using the laws of physics. Most of the magicians in the European country are very good physicists themselves. In fact, there was a time when Nikola Tesla was also a magician. Okay. So, in fact, there is a movie also. If you have time, you can watch sometime called Prestige, which is totally based on, of course, the art of deception, and it will teach you or will give you the insight into how magic is actually performed across the world. So there are many illusionist, mentalist, and so many things. Okay, anyway, so all these things has to do with the perception. You have to play with the perception of the human mind. Anyway, so that's not our topic to be discussed here. So what I'm saying is the law of reflection is something very simple. I mean, the light ray comes, it goes, and it follows the path which offers the minimum time. So that minimum time is kind of inherently built in the law of reflection. If I is the angle of incidence, then the angle of reflection will be same. So the angle I equals to angle R is the second law. And what is the first law? I hope you know this from class 10. So incident ray, a reflected ray,
And mirror are in the same plane.
and the normal drawn at the point of incidence. This is called the normal drawn at the point of incidence. This is called point of incidence. All three lies in the same plane. It is not possible it will come in like this and will go in some other plane, like somewhere here, making the same angle. So you can't change the plane. The plane must be same. That's the first rule. Okay. So now this is the very simple law of reflection. I mean, the first law, you know, second law, this is the second law. And first law is that these three are in the same plane. I will not go deeper into this. So how image is formed by a mirror? So how image is formed by the mirror? So for every mirror to form the image, what we need is a minimum of two light rays, right? So we need a minimum of two light rays to form the image. So this is how we represent the plane mirror. So okay, I'll start with the plane mirror. So a plane mirror is what? A mirror with infinite radius. So you can think that a plane mirror is also a mirror of infinite radius of curvature, and to form the image, what we need? We need a minimum of two light rays. So let's say if this is the object, so any light ray which will hit the mirror at right angle will bounce back on the same path. That's called the retracing of path. So if a light ray will hit the mirror exactly at right angle, the path it will travel is the same path. So it's called the retracing of the path. So this is the incident light and this is the reflected light. I hope this is clear.
Yes.
But this is not sufficient to derive the image. We need one more light ray which can assume at some angle. And this light ray We'll actually go this way. So this light ray is coming this way because it's hitting the surface at some angle. This will theta, so it will reflect back and same angle theta. And now we have two reflected light ray. I can name it one dash, two dash. So one is called the incident, two is called the incident. And if you look at the incident rays as received by the mirror, I hope you can see this. So this incident ray is coming hitting here, or this is hitting here. So at these 2 points, if the mirror will try to trace back the incident light, it will come exactly at O. Correct? You can see.
Yes.
So by retracing the incident ray, we can come back to O. It means O is which kind of object?
Real object.
Real object. So we have discussed this about the real and virtual. So this is the real object. Why we are calling real? Because we can come to the point O by retracing the incident rays. Now look at the other part. If you look at the 1 dash and if you look at the 2 dash, look at this one dash and 2 dash. These are reflected light ray, and if you trace back, will they meet ever?
No.
So what option we have?
Virtual image.
We have to trace it back. We trace it back. Okay. We need to trace it back. So which means the image that we are going to get. So everything which is virtual, we denote by the dotted line. We don't use the bold line. So at this point, you can reach by tracing back the reflected rays, and that is why this is called the image of the object. And because it is not, I mean, happening naturally, I mean, we are not coming actually here. We are coming here only when we are reproducing backward, and that's why this is called the virtual image. So plane mirror will form a virtual image for which object? Real object. Understood? So plane mirror forms the virtual image for the real object. And because of the reflection property, you can say this is also theta, like corresponding angle. This is theta, which is alternate angle. So you can see these two triangles are congruent because of the ASA property. So this angle is also same.
Yes, sir.
If two angles are same, then so this is the common side, right? This is the common side. So if two angles are same, and if the one side is common, then we can apply the congruency concept from class 10.
Yes.
And therefore, these two triangles are congruent. Therefore, if the incident if I name it P point, then OP must be equals to PI, which simply means distance of object with respect to mirror, distance of image with respect to mirror must be equal, and that is the first property of plane mirror. Because of the plane mirror reflection property, these are geometrical properties. That's why the chapter is called geometrical optics. We are not applying anything from physics. It's just like I'm applying geometry, and what we are doing extra is we are applying the laws of reflection, and that's why this is called the geometrical optics. You need to know geometry. That's it. So because of the congruency, we have proved that. Okay, let's conclude. So triangle OPQ is congruent. How will different wrote the congruency? Equal and this the wiggle symbol. So a triangle OPQ is congruent with triangle IPQ. So all sides will be equal now because it's congruent. It's not similar. So OQ will be equals to IQ. PQ is PQ because that's common side, and OP equals to I. and we prove the simple. So if I call this as D edition, this is also D. So now what we can see that in case of plane mirror, if the object is real, the image is virtual. But plane mirror can form the real images also. When the plane mirror can form the real images. Tell me. So for real image, what is the rule? What is the rule for real image? The object must be virtual. If the light ray itself is coming this way, then can you get the object by tracing back the incident ray? Yes or no?
No.
So to get the object, you must extend the incident ray in the forward direction. So this object is called which object?
Virtual.
And if you use the laws of reflection, which you know very well, I'll just say it. So the reflected light ray will be something like this. So what we can see that these two light ray, these are reflected light rays. Okay. And are they meeting actually? The answer is yes. So because they are actually meeting after reflection, so this must be the image. And which image? So now this is against what you studied in class 10th, that plane mirror from the virtual image. But that is the reason because the object was real. So the way to say is plane mirror forms virtual image of real object and vice versa. Okay, that is the takeaway. So plane mirror form virtual image of real object and real image of virtual object. Is this clear?
Yes.
So don't just keep in mind that okay, it forms a virtual image. That's only for the real object. As you change the condition, things will change. So now we'll see some properties of reflection. So the first is like effect of rotating a mirror. So let's say we have a mirror in this position in the very beginning. and the let's say light ray is coming at right angle. I'm taking this intentionally so that if the light ray is coming this way, then after reflection it will go back like this. Okay. Now, what happens if I tilt the mirror by some angle? So let's say you tilt the mirror like this. Now, the moment you tilt the mirror, the normal will change, isn't it? So the new normal
Yes,
will be
sir.
like this. So the angle of rotation of mirror will be the angle that the incident ray will make with the new normal, correct?
Yes.
So the reflection property says that how the light ray will go back. The same light ray will go this way, right? And this angle will be how much? Theta. So this is the one. This is the one dash, and now this is one. This is the one double dash. So what you can realize from here, if you tilt the mirror by theta, the reflected light ray will tilt by
Theta.
2 theta. So the reflection is now earlier it was going this way, now it is going this way. So how much it has turned? So
So can you repeat again?
if you tilt the mirror by theta, how much a reflected light ray will turn?
From the original to theta.
Of course, original only we asking. So what you can write here? If mirror is rotated by angle theta, then the reflected light will turn by 2 theta. Okay, I need to mention. Is this clear?
Yes.
Yeah. So that is how we understand. So let's say if you want to rotate a light ray by 60 degrees, then how much you must turn the mirror? Only 30 degrees, isn't it?
Yes.
So for example, if we have a mirror like this, exactly vertical position, and light ray is coming exactly at a right angle horizontally. And also one more thing that you need to observe, that if you are turning the mirror in the clockwise sense, the light is also turning in clockwise sense. So the rotation sense will be same. Understood?
Yes.
So sense of rotation is going to be similar. Also, the sense of rotation will be same. Okay. So the sense of rotation will be same. If you tilt the mirror by theta, then the light ray will. So if you tilt the mirror clockwise, then light ray will also the reflected light will also turn clockwise. So the question is here. So to tilt, okay, let's say the light ray is coming horizontal. I want to make the light ray vertical. How much I must turn the mirror?
One.
Hmm? What is one? 1 degree?
So 1 into. Okay.
One?
180.
So to make the light ray vertical, go this way. How much I must tilt the mirror? So what is the rotation of light ray? How much angle?
So 45 degree.
Yeah, it must be 45. No? You're turning the light ray by 90 degrees, so the mirror must be turned.
45.
So the reflected light ray was going this way, and now the reflected is going downward. So earlier it was like this. So you have turned in which sense? Anti-clockwise. By how much degree? 90. So the mirror must be turned by 45 degree from the actual position. So if you tilt the mirror by 45, it will throw the light ray by 90. So if you know how much you want to turn the light ray, you should know that only half rotation is required. And you must understand that we are comparing the reflected light, not the incident. So this is the reflected in the beginning position in the first scenario. Now this light ray is turning here. Okay. So I hope this is clear.
Yes.
So whenever you want to turn the light ray by any angle, just so this is how we design the periscope. You know, periscope. Have you seen the periscope?
Yes, sir.
So there are two ways in which the periscope is designed. One is using the prism, which uses the TIR. Another is by using the reflecting mirrors. Let me design this. It's very easy. So what we are supposed to do? We are supposed to make two mirrors. One kept at 45 degree here. Another. So if you make the two mirror like this, then any light ray which is entering, this is the light ray is coming from the horizon. After reflection, it will become vertical, and the vertical will become again horizontal. Uh,
Sir, we have to align them by 45 degree so that the
Okay.
reflect should be 90 degree.
yeah,
Okay.
that's true. So by aligning at 45 degree in both cases, the light will turn back, and what we see? We see light. So it really doesn't matter where the object is. So this is like you are inside the ship or cruise, and this is the periscope which is extending outside. So of course, during war, you will not go outside to see the enemies. You may be hit by a bullet. So you remain inside, and then simply using the laws of reflection, this can be designed, isn't it? That's pretty simple, I think. So the same is also designed using the two right angle prism with reflective index good enough to make the TIR. So we'll see in the prism chapter how it is designed. So this is simple periscope. So there are many use of this. So mostly in case of projection. So again, as I said, uh, if a person is standing at the base, okay, so we can put a mirror here, and by putting the mirror, this will have the reflection, and this will go back. So image is like carried forward to the top, to the stage. So person in image can be carried till the top, and that is how the magic will be performed. So a woman will enter the box and will come unscathed without getting hurt by the swords, and then you will clap. Okay, so that's simple. So it's a lot more than this. It's not easy. Of course, magicians plays. I mean, they do hard work to design all this act. So the next part is the rotation. So we will talk about deviation. That's very important. So we'll talk about the concept of deviation. So any light ray hitting a mirror if any light ray is coming at some angle, hitting the reflecting surface, so what is the role of mirror? What mirror does actually? If there is no mirror, what will happen? The light ray will continue like this. So this is called the expected path of the light ray. Now the presence of mirror in its path will change the path of the light. Of course, using the concept of reflection. So if you call this as theta, this is let's write I. So if this is the angle of incidence, this is also I. So what mirror has done that it has turned the light ray from the expected path by this value. So deviation caused by the mirror is how much? Do you realize this?
Yes.
So what is the meaning of deviation? How much the reflected light ray must be turned to match with the incident ray. So you must turn by pi minus 2i, isn't it?
Yes.
As this is straightforward. So deviation is simply how much light ray has turned from the its original path because of the interception by the mirror. The answer is pi minus 2i. Any ambiguity in this? Any doubt in this?
No, sir.
So if we have multiple mirrors, deviation will be either added or subtracted depending on the sense of rotation. So let's say the light ray is coming here, hitting the mirror. So if if you hit at an alpha angle, you go to alpha angle, correct? So this is the first mirror you intercepted. Then comes another mirror like this. And now this mirror will do the same thing. If I call this angle as beta, this is also beta, right?
Yes.
So the question is, what is the net deviation suffered by the light? So the first mirror will turn the light ray by this angle, which we call delta 1, and second will turn by. So now tell me, is the sense of rotation same or different? The sense of rotation is
Same.
same. So in such case, we add the deviation of each meter separate. So net deviation data is delta 1 plus delta 2, which will be how much? 5 minus 2 alpha. Okay. Now it is
Sir,
quite possible.
clockwise is also positive.
Pardon? No, no,
Clockwise with the
it has
plus.
nothing to do with the clockwise or anti-clockwise. When we have multiple rotation, then you can choose one as positive, other as negative. If you have only one, then just take positive. Okay,
So can you show the previous plus?
just a minute. Done. Okay. So it is quite possible that the sense of rotation may be different. So look at this example. So the first mirror will turn by this. So in this case, the net deviation will be how much?
Del 1 minus del 2.
Either you can say one is positive, other is negative, because it is opposite. So you can choose, if you choose clockwise as positive and anti-clockwise as negative. If the net answer is positive, it means the net deviation is also clockwise, and vice versa. So this is not a big deal. I hope so. Okay. So if you just want to know the value, you can take a modulus, but okay, we can write like this, or it really doesn't matter. What matters is if the assumption and the answer will have the same sign. If you assume something as clockwise as positive and the net answer is positive, which means the net deviation is also clockwise. Understood? And vice versa. So there is a question. There's a very famous question. Must solve. So two plane mirrors are inclined to each other at some angle theta. If a ray suffers reflection from each mirror exactly once, and the total deviation suffered by the ray is same as the angle between the mirrors, then find the angle between the mirrors. So what's the angle? When this will be true? You can think this way, like maybe two plane mirrors, maybe I can just do randomly. So a light ray is coming in such a way that it only suffers one reflection from each, something like this, some random. You can choose whatever you want. And the total deviation is matching with the theta. So for what angle theta it is possible? Try this. Questions clear, guys?
Yes.
Yeah. So just I'm giving you 2 minutes to solve. Use the property of geometry to prove it. Got the answer?
Yes, Lawrence. So 2 pi minus 180 by 3.
2 pi minus
180 by 3.
2 pi is 180 itself, no? So it's 0. What are you saying? 2 pi minus 180 is what? Okay, pi by 3, you mean to say. So sometimes you have used 180, sometimes you have used pi. Why you are doing this? Okay, anyway, see if I draw a perpendicular here. So we can say that the net deviation is how much? 2 pi minus 2 times alpha plus beta.
300 degree.
Pardon?
300 degree.
100.
300.
300 degree. Okay, what does it mean?
Like in pi form.
Okay, anyway, leave it.
Pi.
So now this is the equation. This is the net deviation, right? The net deviation is this much. Pi
So
minus 2.
90 degree.
Leave it. So this is how much? 90 minus alpha. This is. So this is simple geometry. If your normal is making beta, so the other will be. So we also can use a triangle property which says that the sum of the angle is how much? So basically alpha plus beta is nothing but theta. So from 1 into 2 pi minus 2 theta is equals to theta. So theta is 2 pi by 3, which is 120 degree. Okay.
So I got the same two equations.
But your answer is something weird, no?
So I
Hmm.
did mistake on the calculation.
Very good. Keep on doing it. So one day it will be better. So this is a simple question, simple answer, not a big deal. Next. So again, imagine we have two plane mirrors inclined to each other some angle theta. A light ray is coming parallel to one of the mirror. You can choose any mirror as you want. So this is the incident light, and this is your so so this is the incident ray. This is the okay. Two mirrors are inclined to each other like this. Okay, so let me add the question. So try to think about it and tell me the answer.
So retrace is the path of
The same path, like the way it came.
the incident, right?
Hmm. Go back to the original. Like retrace means you hit and then you start coming back using the same path from which you traversed before.
So pi radian,
Hmm?
180 degrees.
Anything, eh?
So it is only possible. Third reflection is when the mirror.
If it is 180 beta, then how the light, how the ball will reflect? It will just go away. Na? What will retrace? And how it is possible to retrace? Okay, you're not getting the meaning of retracing. That's why the problem. It is something like this. I mean, okay, I just have to exaggerate the diagram. If I go see it's 90 degree. So if the angle is if I hitting at this angle, if it is 90 itself, then it will retrace from here. But this is the second reflection. But what is the question? After third reflection, this happens, which means it is somewhere here. I mean, of course, it's difficult to draw because the diagram itself is not accurate, but it goes something like this and hits the plane, the other mirror at right angle. So the moment you hit at right angle, it will start retracing here. And then it will go back here and it will go back eventually. So here, if I draw hypothetically the right angle like this, so this is theta, this is also theta, this is alpha, this is also alpha, and then you hit at 90. But you can find alpha, why? Because this is 90, this is theta, this will be how much? This will be 90 minus theta. So alpha is theta actually. Alpha, if you look carefully, alpha is theta. In the you have to use two triangle, one this triangle, another the corner triangle. Okay. So if you use a corner triangle, you can see clearly this is theta 90. This is how much? And if you draw a normal here, this will be how much? Again theta. So this is the alpha basically. Something like this should happen in order to make this phenomena possible. So what is the angle? This is theta. This is also theta. Law of reflection. And then you can see clearly that 3 theta is equal to understood.
Yes.
Now there is a nice question we can make from the mechanics. Now what is the mechanics? The mechanics says that there is a cave. Maybe there is a two plane. You can see, imagine there are two planes which are inclined to each other like this at 30 degree. Imagine. And then what you do is you throw a ball parallel to one of the. So you throw a ball parallel to one of the other ball, and the ball makes perfectly elastically. Ball makes perfectly elastically. So what is the closest separation that the ball can go till the O? So such that the ball. Okay, I mean, it's like yeah, that's the question. So the closest it can go will be how much? Because of the angle reflection property, it will eventually trace back, isn't it? So you cannot keep on going forward. You have to eventually turn back. I hope this makes some sense to you, what I'm saying.
Yes.
So the nearest point the ball can reach is this point, correct? Okay, any just okay. I need to give some more variables to solve this question. The need to find the nearest point. I need to give some dimension also. But okay, you can. I mean, question can be made using the law of reflection in mechanics using the concept of perfectly elastic collision because the behavior of perfectly elastic collision and the reflection is quite similar. Okay. Anyway, so I'll give some other interesting method to solve this question. Is the answer clear to guys?
Yes.
Yes, sir.
So there is a even better way of solving this question, and that better way is actually every time you reflect, what you can do is if you reflect once, so the light is hitting here parallel to this mirror. So it will hit some angle. maybe like this. And reflection is what? Reflection is, if you try to draw the mirror image, the mirror image will go like this way, right? So as for the question, it will hit the mirror like this. If you just turn it other way around like this. So this is difficult for you to understand. What I'm trying to explain is that instead of drawing the reflection, what we can do is, there is other way of doing. You take the next mirror at the same angle, somewhere here. And then what you do is you continue the line without altering the path. That's the whole idea. No need to change the path, rather shift the mirror or take the image of the first mirror with respect to the other mirror. So again, if you take one more, it will be here. Then take the next, then take the next. Every time you will turn by theta, the light ray will keep on going forward, forward. And what I'm saying is that after a third, I mean, when it is the third reflection, when you are hitting for the third time, so you hit the first mirror, you hit the second, then you hit the first again. So mirror one, mirror two, mirror one. Okay, I can say like this: mirror one, mirror two, mirror one dash. The mirror two dash, the mirror one dash, double dash, then two double dash, and something like this. So the idea of solving question like this is taking a reflection is a challenging task. So what we do is we keep on taking the reflection of the mirror itself. So first, second, okay, you hit the first mirror, second mirror, and the third mirror is take the reflection. So what I'm trying to say that the light ray which is coming, if you can get it, then let me know. I think it's difficult for me to explain what I'm trying to explain. The reflected ray will go like this. Okay, so in our question, we are supposed to find the angle theta such that it makes the hit at right angle. So for what angle theta? This is right angle. So this is the third mirror, first, second, and first dash. So the theta must be chosen in such a way that when you hit like this. And it is same as taking the reflection in this side. Okay, of course, I have to make a compulsory 90 degree. So when this is possible, so this is theta, this is also theta, and you can see the 3 theta is in the triangle on the left. Now this we can actually use for the any number of reflections. So let's say if I ask you that if it retraces after first reflection, second reflection itself. Second means what?
Dr. Freddy.
It means the light ray is coming and it is hitting this mirror 90 at right angle directly. Okay. In that case, this is theta, this is theta. This is how much? This is theta only, it's given. You can clearly see the theta is how much? 45 degrees, correct?
Yes.
So after second reflection 45, after third reflection 30. So after nth reflection, or let's make it fourth reflection. Now I want that after fourth reflection it should trace back. After fourth reflection, what does it mean?
90 by 4.
How much? 90 by
4.
4, which is like 22.5, correct? So retrace, so retrace after nth reflection must be equal to 90 upon n, correct? So you can solve for any value. So if it is second, third, or you can do the same thing. Like if it is the fourth reflection, let me show you. So fourth means one, one, two. So two is till here. Two is done. Then three means draw one more. This is three, and then four. And each angle must be theta, 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 and the light ray coming after reflection must hit at the right angle, something like this. So if it is hitting, I do not know this in this way. Let me confirm if this theory will valid or not. Can we extend this theory? Yeah, we can extend theory because if I choose n equals to 1, it must be like this, and it is retracing. So it is 2 for 1, 2 for 2, 2 for 3. By induction, we can say it must be 2 for n. Yeah, this is a good theory actually. But it is 2 for the 1, 2, 3, 4. So of course we can make it for any value. Okay. Okay, all right. So from plane mirror, we have seen some of the basic properties. Let's do one nice question. Question is like this. So we have a plane mirror, and this mirror is rotating at constant angular velocity omega, and the mirror is hinged at the center. Let's say mirror is hinged somewhere here. And there is a vertical wall which is acting like a screen, and the distance between the wall and the center of the mirror is, let's say, d. Okay. So there is a flash torch, or flash, simply flash or torch, you can say. There is a torch which is illuminated somewhere here, and the torch orientation is constant. Light ray is always coming this way, but the mirror is turning. So this light is coming always like this. So at an instant when the mirror is horizontal, let's call this as horizontal. This angle is, let's say, 60 degree. So at that instant, the light ray after reflection must be reaching the wall somewhere here, and it will create a spot. But because mirror is in the rotation, so the spot will not be reached. It must have some velocity. So what we are supposed to find is what will be the velocity of the spot at this instant when angle is theta. So find the velocity of at a given instant. Okay, let me share the sheet for the geometrical optics. Yeah, this is the question number 3 from the page number 22. Something like this. I mean, not exactly. So if you go to the page number the 22, question number 3, this is the exact problem. If you want, you can solve this problem so that you can match the answer as well, right?
So,
Yeah.
so do we have to do like this, that velocity in the same direction? Like we have to take the component of v in the reflection direction.
See, I have asked question you're supposed to solve. If you're not able to, then I'll give you the idea how to solve. So first you try. And why you need to try is because, okay, I'll give you the hint. Assume this distance is y from the this location till this location. So y you can find in terms of d and this theta, correct? Or let's call this as alpha. That's better way of writing. Alpha I'm taking not from mirror, from this line, the dotted line. So you can easily correlate the alpha with d, but alpha is a constant or variable.
Variable.
You have to differentiate alpha. And what we have studied that from the deviation rotation property of mirror, that if the mirror will turn by omega, then the reflected light ray will turn by
2 omega.
2 omega. So that is what we have to understand, that the alpha will change by 2 times of so d alpha by dt you will get as 2 omega. So that's the rotation property of the mirror. So this is the reflected light. So the spot is made by the reflected light. Understood? So incident light is fixed in terms of direction, but mirror is turning. So theta becomes variable, and so the alpha. So rest I can, so you can solve from there. You have to find the relation, then differentiate, then substitute. You will get the answer. Okay. So try this for a few minutes, then answer.
So velocity equals omega y square plus d square by 2.
Pardon?
Omega times y square plus d square by 2.
But y is not given, na? Y is something you assume. What is given is d.
Uh,
So you must substitute, right? Are you solving the question number 3 or this question?
so the one you gave on the 3.
Okay, anyway. So you can write here 10 alpha equals to y by d. This alpha is with respect to the dashed line. Alpha is with respect to dashed line. Y becomes a d 10 alpha. dy by dt will be d sec alpha d alpha by dt. So this is the velocity of the spot. V d is d sec square alpha. So because alpha is 30 degree here at that instant, and d alpha dt we can write as 2 omega. So V turns out to be 2 omega d, and sec theta is how much? How much? So cos 30 is root 3 by 2, 2 by 3, so it's 4 by 3, right? So can you attempt the question on page 22 and see if you're getting the matching answer, because this is some hypothetical value of which I have taken. So hopefully by taking the proper value, you should get the proper answer. Don't try to copy paste, try to understand and solve.
The PDF page number 22 or
PDF I have shared right away. You can see.
so no, like in PDF 22 or that
No,
20
no,
or something.
the book page 22. I think both are similar, but it may be different in different yeah, tools.
Yes, sir.
Yeah, I think this is question number 3. Can you see that?
Yes, sir. Yeah, question number.
Okay, so try it.
So can you explain that d alpha by dt equals to 2 omega 1 happens?
Yeah, so in any effect of rotation of mirror we have seen, if the mirror will turn at a rate of omega, then the reflected light ray will turn at which rate? So the omega of this light ray will be
Two omega.
mirror will turn by omega. So if mirror will have that rate of change of theta, then the reflected light ray will change at 2 theta. Correct?
Yes.
Understood? No. Yes, maybe.
Yes.
Okay, think this way. Imagine this is the light which makes an angle theta. It will reflect at this angle theta. Now you turn the mirror by, let's call d alpha. Then this light ray will turn by how much?
2d alpha.
2d alpha. Correct. Understood.
Yes.
So if we turn the mirror by d alpha, then the light ray will turn by 2d alpha in the same sense as before. So okay. So the d alpha by dt is the omega of the mirror. So what is the omega of the reflected light ray? Understood?
Yes.
Okay. Well, that's good enough. You can go ahead. So at that instant, it is the snapshot taken at a given instant. but in reality it is time bound situation, so it is keep on turning all the time. So what you're looking at in the diagram is one instant situation. So theta is not a constant quantity. Theta itself is a variable quantity, and because it is variable, it will change. Okay.
So got the answer.
Answer is matching.
Yes.
Yeah. Okay. Interesting. Okay. So next concept is, am I audible, guys?
Yes.
So what is the minimum size of mirror that you need to see yourself completely? Like you must see your bottom and your top. Okay. So what is the minimum size of mirror required? So let's say, uh, okay. So let's say this is the person. Some person is here. So this is the tip of the head. Okay, top of the head. So eye level will be much somewhat below, right? Let's think of eye level somewhere here. Okay. So this is your eye level. So what is the rule of the image formation? To see the top and bottom, the light must reach from the top and the bottom to your eye level, correct? That is how you see. Understood what I'm saying?
Yes.
So right now I have no idea where the mirror should be, but let's say this is the plane in which the mirror will be somewhere. The rule says that wherever it is, the light leaving the tip must come back to this eye level. So the light ray must reach here from leaving the tip coming to this point and leaving the bottom coming to the eye level. So from the law of reflection, the mirror must be at the midpoint of the eye level and the bottom. So some mirror must be present here, and the other portion of the mirror which we need is the eye level and the mid of the eye level and the tip of the head. So any mirror below and any mirror above is like a kind of bonus. It's not required because to see the full image, we at least need mirror between these two portions so that the light can be reflected back to the eye level, which means the light ray traveling from the foot will hit this part and following the law of reflection, making the same angle will reach here. So because of the you can think of similar triangle concept, this must be the midpoint. And this is the ray path. The ray is traveling from the bottom and coming to the eye level. And same thing will happen for the tip, right? So light ray traveling from here will hit the mirror and will come back to the eye level. Of course, it is following the same angle relation. So if this is alpha, this is also alpha. Of course, alpha theta will be different. So what we can say that if I call this is x, this is also x, and if I call this is y, this is also y. So if h is the height of person, Then what you can say? The 2x plus 2y must equals to h. X plus y is how much? H by 2. And if you look carefully, what is the length of mirror? Therefore, the length of mirror is how much? So minimum length of mirror that you need to see yourself completely is h by 2. It is clear?
Yes.
Okay. Imagine if this is you, the mirror is exactly half of your length. But the problem is someone has kept the mirror like this. Okay. So the question is like this. Situation has changed. Now what is the change situation? The mirror is h by 2 but kept like this. The tip of the mirror is at your eye level. So there is no mirror above the eye level. So what is the length of the human? I mean, what is the which length part, or what is the length that you can see in this case now? So length visible to eye will be. Tell me. Then I need to give the eye level also, no? So this is let's call it small h. The eye level is small h below. Now what I'm giving. This is not good. Just, just this is not a good question. This is easy to solve. Okay, so I think there's a question which you can solve on the sheet itself. Just go to sheet. Everyone, go to sheet. So there's a challenging problem. Yes, I think this is the question. Question. This is the question number 2 of the same page, page 22. Sorry. Question number 2, page 22. Solve it. Am I audible, guys?
Yes.
Yes, sir.
Solve question number 2, page 22, the same page. That was a question actually. I wanted to create. Question. So that will clear your concept that whether you have understood this or not.
So can you show us this?
Yeah, tell me.
I'm not getting the answer.
So, okay, what is the question? Let me check the question first. A plane mirror is 50-meter long, right?
Centimeter.
Yeah, 50 centimeter. Hmm. With its lower edge 50 centimeter above the ground. So this is also 50 centimeter. A man stands in front of the mirror at a distance 2 meter away, which is of no use. If his eyes are at height 1.8 meter, which is 180 centimeter. So 1.8 meter, right? 180 centimeter, which means, okay, I don't have space to show. Oh, let me do it. So the man is 180 centimeter. So roughly halfway. uh, you know, yeah, that's correct. Now let's keep it like this. So half is mirror and half is the space distance. So 50 centimeter is the mirror and 50 is the space from the ground. This is 2 meter, which is 200 centimeter. And this is the eye level. Okay. If his eyes are at this, okay, then the length of the floor visible to him due to reflection from the mirror is. So what length of the floor you can see? So that to see the length of floor, you can retrace the path like this. So light ray must be coming. So I hope you can understand this part. This must be 80 centimeter. If the light ray is coming here, it must be coming from where? It must be coming from 80 below, something like this, correct? And the light ray from this portion will travel and will reach the human eye. The other ray, which can also reach a human eye, is hitting the extreme end of the mirror. So 80 plus 50 is how much? 130. So it is capable of going 130 below, but okay, we don't have that. So you can say this angle is beta. This is also beta. So the part of the flow which you can see is only between these two, right? Extremes, and you're supposed to find this length. Now, can you do this? If you have understood this concept, so only this part of the floor is visible, no? Because the
Yes.
rest of the place the light ray cannot go actually. So this light ray after reflection can reach here. So what we do is we use the extreme of the mirror to see where the light ray can go eventually. And then what we do next is we use the similar triangle and all concept. All right. So I think you need to find this length only, this part, because you can see maybe behind. Yeah, try this out. Can you try this out now?
Yeah.
So I think we can see this is beta. So if I call this as a x, some value, what you can say d. So 50 by d, it's like tan beta, is 130 by 200. 130. So d turns out to how much? 130. Okay. So we got d equals to 1013 centimeter. All right. And the other you can find as alpha. So tan alpha you can attach. This is tan beta, which will give you this is tan alpha will be. So if I call this as d dash, just I don't know whether this I need or not. So tan alpha in the upper triangle will be 80 by 200 equals to, in the lower will be 100 upon
200 is very nice.
that's correct. So 200 plus d dash turns out to be so d dash is how much? 200 into 2 by 8, 450. So the total distance visible is how much? The total visible length will be how much?
50 plus 200 minus 1000 by 30.
I think d dash plus 200 minus d, right? So d dash plus 200 minus d should be the answer, right? Isn't it? And do this. How much is this? So it is 2250 by 13 centimeter. And the answer is given in meter, no? Meter.
Yes.
So this will be multiplied by 2 in the numerator. So
45.
4500 by 26 centimeter, which is 45 by 26 meters. So x should be 45. Can you check the answer? Is it
So
matching?
it's 45.
Oh, that's good. So this is the application of a reflection. I mean, just pure geometry which we need to use to arrive at the answer. Okay. Anyhow. So try these questions like this. The question number one is again similar, using the reflection property to see where light ray can go. So there is a very nice question. Let's say there is a mirror of length L, and this is the, like, let's say, ground, and we have a source of light somewhere anywhere. So imagine light cannot go directly on the ground, so light ray will reach the ground only after reflection. So it can go here, will hit, and will come back somewhere here. The other extreme is here. So this region is the light ray is reaching, correct? Okay. So the light ray is reaching here. So if the length of the mirror is L, what will be the length of the shadow or the, okay, you can mention the spot, actually light spot, not shadow. So how big will be this length? And does it depend on how far the source is, or will it be same for all source? So I want to know this x. And because anything is not given, it means it only depends on L, which you need to realize. But anyway, so they may confuse you by giving the height between the mirror and the plane. Okay.
Which is given.
No, only L is given. And you're supposed to find the x. And it's pretty easy. So if I call this as D, this is also D. And the bigger one, if I call it D dash, this is also D dash. Right? Simple reflection property. And the D basically is this length. This is D, and this is D. Okay. So basically, what is X? It's very easy answer. 2 D dash minus 2, correct?
Yes.
Mm. Mm. So if you add, you can say 2D plus x is equals to 2D dash, isn't it? So do we have some relation with L? How L is related to D dash or whatever? Okay, this is confusing. Okay, if I do this way, so basically the D dash is nothing but D plus L. Can you see that?
Yes.
So D dash minus D itself is L, and that's why the answer is simple to L. Basic geometry. Nothing more. I hope you can realize the D dash and D relation. If you add L to D, you'll get D dash. Do you realize this?
Yes.
So the X turns out to be 12, which means if the length of the mirror is constant, then shadow will be constant no matter where the source is. Because if the source will go away, both light ray will go farther and the gap will be maintained. Okay, no matter what. So this is again important to remember. This is like a remember this answer. Okay. But you can see that the source level and the ground is having same level, so they are not on different levels. If you have the ground somewhere here, it will extend more than that, right? So the level is maintained. That's why the answer is maintained. So don't apply this blindly anywhere. If the level goes below the source, then the answer will change. So here comes the next concept from the plane mirror. So the first concept is, let's say you have a wall behind you. The height of the wall is h, and you can assume the person to be anywhere. This is the only I will do only the eye level of the person. So the eye level of the person is here somewhere, and the mirror is somewhere ahead. Let's put it somewhere here. I don't know where. Let's make it unequal. So the question is, the distance of the eye level from the wall and from wall to the eye level. Let's call it a D1, D2. So how to see the complete wall, or at least you can say top and bottom, not complete. So find the minimum length of mirror kept at a distance D2 away from eye level such that the observer can see the complete. Okay. So that's the question. Question is clear.
Yes.
So if you want to try, you can try. Else I will solve. So the mirror is at a distance d2 somewhere on this gray line or whatever the line.
So is it H divided by
Hmm.
hello,
Yeah, tell me. H divided by
1 plus
1 plus.
D1 plus 1 plus D1 plus D2 by D2.
Very good. So the minimum length will be H upon 1 plus
D1 plus D2
D2
by
by,
D2.
which you can
D2.
rewrite as H upon 2 plus D1 by D2
Uh,
and divide, right? Okay. So if I call the D1 by D2 as a ratio R, then the L minimum turns out to be so D1 is the distance from the wall. So it's easy to remember because the light ray will travel from where to where? From wall to the eye. Wall, eye. Or you can do take the reflection, right, of D. So the better way is extend this line and extend this line behind. And this is very easy to solve, right? Mm, some- extend this. Okay, anyway. So the whole idea is this is also D2 only, and then it's easy for you, no? So you can see the distance part. So the length of the mirror is this much only, no? So you can directly write H upon D1 plus 2 D2 is L upon D2 similar triangle concept, and we are done with the answer. So you can get the answer in one line using the similar triangle. It is clear?
yes.
So if the person is exactly in the midway between the wall and the mirror, the answer will be H by 3. If D1 and D2 are equal, then I hope you did. If
Yeah.
D1 D2 are equal, so if a midway between the mirror and the wall, then the L minimum will be how much? So there are many questions that you can solve from the plane mirror. So the one more concept which I need to discuss from plane mirror is the rest you can solve and get the idea. Yeah, motion analysis. So if we have a plane mirror, so imagine a person or if a particle is moving this way. So we will have two components. Let's call this is theta. So we will have two components. One is horizontal v cos theta. I mean not horizontal. The component normal to the plane of mirror. So the image will move symmetrically because mirror will create the symmetrical image. So if this is the object, the image will be like this, isn't it? The other way of thinking is that the component parallel to the plane will remain unchanged, and the component normal to the plane will be reversed back. So if this is the v perpendicular, this will be in the reverse direction. But a v parallel will be unaffected. So if this is the v parallel for the object, for image v parallel remains same. So what I can say v parallel for object is v parallel for image. V perpendicular for object is minus V perpendicular for image. So the perpendicular component will just reverse because if you try to approach the mirror, the image will also try to approach the mirror because the distance will remain same. So this is a simple question in which mirror is at rest. It's called the fixed mirror. Okay. Also, what happens if we have the moving mirror? So what we'll consider is the object is moving in this direction, which is along the perpendicular. The other component, even if it is present, we can ignore because that will not affect the motion part. So only the normal component will get affected. So we are taking the normal component as vector. So what we know from the definition of mirror that velocity of image with respect to mirror and the velocity of object with respect to mirror, they are always opposite.
So can we do like this? Keeping the mirror fixed and taking the velocity as V naught
Yeah,
minus V.
yeah, definitely you can do that. But eventually we need the answer in the ground frame. Na? So that will give you the answer in the mirror frame. So to go back to ground frame, you have to add one more time, isn't it?
Yes.
So velocity of an image with respect to mirror is simply minus times velocity of object with respect to mirror. So in one dimension, it's easy, right? Vi minus V a mirror is minus Vo minus V mirror. And so what you get is the Vi equals to 2Vm minus Vo. Is this clear?
Yes.
Not clear?
So clear.
So you can see that if the mirror is at rest, if mirror is at rest, then in the ground frame and in the mirror frame, the answer will be same. Vi equals to minus Vo. So they will be equal in opposite. That's a expected answer. But if the mirror is also in motion, then ground frame answer will change. In the mirror frame, it will be always equal and opposite. In ground frame, we have to write like this. So if you multiply by time, so displacement of the image will be, let's call this as x-axis. So displacement of the image will be twice of the displacement of the mirror minus the displacement of the object. So this is also helpful in some situation. So they may ask you a question like this. There is a mirror and this mirror is performing SHM. So the displacement of the mirror is given by the formula A sine omega t. And there is an object which is fixed. So if the mirror will move or shift, the image will also shift. So questions find the amplitude of image because mirror will shift then. So it's very simple because your object is constant, so you can use this relation. So amplitude of image we can write as twice the amplitude of mirror minus amplitude of object, which in our case it is 0, right? So the amplitude of image will be just twice of the mirror. So that's the answer. You can just apply it, or you can do it organically by shifting 2 times. So when mirror is here, then object will be image will be if it is d, then d away. When the mirror is d plus a, then it will be d plus a away. So you can add the value. So we'll get the answer as 2. Is this part clear?
Yes.
So you can do the motion analysis in this way. It's pretty easy. The last concept is finding the coordinate, but that you will study in mathematics also. So if we have a mirror, so if the coordinate of the object is, let's say, x1, y1, so image will be where? Exactly at perpendicular. So object and image will make a line, and the mirror will be the perpendicular bisector of the line, isn't it?
Yes.
So
We have to find the mirror image coordinates.
yeah, so let's say if you know this, I mean, the equation of this is given as, let's say, ax plus by plus c equals to 0, or you can say y equals to n plus c, whatever. Okay, sorry. So if x1, y1 is given, then what is xy? The relation between x, y, x1, y1. So first of all, the basics is that the slope is mutually perpendicular. Then you can say the product of slope will be -1. Of course, in physics we don't need all this. We can solve
So
by
it's
common sense.
-x.
-1. So we can write as slope will be how much? Y minus y1 upon x minus x1, and here it will be minus a by b. So this is the one of the equation. The other equation is what? The midpoint of the object and image must lie on the mirror, or must lie on the lines. Therefore, a into x plus x1 by 2 plus b into so technically solving these two questions is sufficient to get the answer. Okay. Yeah. So
Yes.
yes, you can solve by doing some manipulation.
So we can use the image point formula.
Pardon?
We can use the image point formula.
Yeah, but formula is derived from here only. So how
Oh,
you get the formula? Show me the derivation of the formula. How you do?
so from this only. But because
Do you know how to derive the formula? The formula which you have marked up.
no, sorry.
Then what is the benefit of learning maths? If you mug up the formula in maths, it means your math learning is almost negative. We never study maths in terms of formula. If you think maths is formula, then you don't know anything about maths. That's very bad proposition. So make sure that in maths you know only derivation. Formula, if you don't know, that's totally okay. In J Advanced, why most of the students fail to score in maths? The reason is they don't learn maths; they learn the formula. And there is no formula in maths. I don't know even a single formula in maths. But it's very easy to derive from basic scratch. Just do the regular stuff, use definitions, and you will get the answer. Anyway, so use this basic method to get the answer. If you know the formula, if you want to use, you can use. Not an issue. So what else we need in the plane mirror? I think we are done with everything in plane mirror. There are some questions left which you can attempt on your own. Just let me check to choose something. So you can solve this book. Yeah, now image formation by two plane mirrors that I have left totally, and the vector equation of the plane mirror. Okay, so these things I'll do in the next lecture. So it will take one more lecture, not one more lecture, 1 hour extra, and we should be able to finish the plane mirror part thoroughly. So you can start solving the plane mirror from the sheet which I have shared with you, and get the answer. All right.